Good evening, everyone. Uh, so now we're going to solve sum of round numbers, code courses 1352 problem A. This is basically a division 4 problem. So let's take a look at the problem. Uh, yeah, so basically you're given a positive, strictly greater than 0 integer, and it is called a round if it has zeros after its like after except its leftmost significant digit. All the other digits should be 0. So let's take an example, 4000. So other than this digit, other than the leftmost digit, every other digit is 0. And also, to be honest, you can consider a single digit number as also a round, a round as they describe, because there are no digits after that, so you can basically consider them as 0. So is 800, so is 90, and so on. But you can see 110, even though it's ending with 0, it's not a round because 1 is there. And the same with 707, 222, 1001. Yeah. So I guess just by looking at it, someone can easily guess that the something related to modulus is involved in this problem. So let's try to see the approach. Okay, so basically this would be our input. Let's sorry, let's copy it here. And now what we're gonna do is uh, let's take this number as an example, right? 9876. So as you all know, that the modulus revision is basically basically outputs the remainder of a modulo b. It outputs the remainder of of uh, of a when a is divided by b, something, and the remainder that will be basically the output of a modulo b. So and we all are very much familiar with the concept where if uh, x is a number, when it is x modulo 10 will be equal to some other value which is a reminder. Why? If greater than x is greater than 10, if x equal to 10, it will be 0 for x equal to 10, and it will be x for x is less than 10. So any value, if we are taking x any value which is less than 10, then the output of the modulo operator with 10 will be the number itself. So I'll give you an example. Yeah, so let's say you take let's say you take 7 and do modulus division with 10. The output would be obviously 7, because 7 is less than 10. How are we going to use this? So uh, let's say we take 9, 8, 7, 6, and we do modulo operation with 10. Output we would get is it's the rightmost digit. Okay, that's what we get, right? uh, yeah. And 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 I guess anyone can see a pattern here. If we somehow are able to eliminate this number, then we would get 987. And again, if we do modulo division with 10, we would get 7. And if somehow magically we are able to eliminate this number, we would get 98. And if we do the modulo again with 10, we would get 8. So it's very clear that after each and every modulo division with 10, we are getting the uh, rightmost part, rightmost digit of the number. So the main question lies in in how do we eliminate the number though? So let's take 9876. Let's divide it by 10. What will it become? That's very common. I guess everyone knows that. And it's zero point 0.6, right? Just it's just 10, right? A decimal. And it goes here like that. So so what if so now what if I guess everyone is this is a floating point, right? A decimal set. And what if we apply int? Int means it is integer value 1, 2, 3, 4, so on. No decimal points like 3.2. All these are not involved. So if we apply int to it, then it would transform into 987. And surprisingly, this is what we wanted, right? So basically, we have found a method where we can easily eliminate the number which was 6 here. So now what we're going to do is wait. Now we'll try to apply the same logic on this number. Let's take 9876. Okay. First, let's modulo with it with 10, and we would it would pop out the value 6, and then we would divide it with 10 and convert into n. Don't forget it. So that we would get the value 987, and this 6 will be eliminated. And we again this will basically be a loop, okay? And 987 will again do modulo with 10, and what will get 7, and again and again will divide and again we'll divide the 987 by 10, and we apply in, so it will become 98, and again we'll divide modulo with 10, which will give us 8, and again we'll divide it with 10, which will give us 9. So and now here is the base case, 9 modulo 10. Yeah, as you all remember, I've told you if x is less than 10 and we do x modulo 10, the answer would be x. So simply the answer would be 9, right? So I guess you've kind of uh, got the how what's going on here. So let's try to implement this using Python. So yeah, let's just review the problem statement once. So basically, the first one contains integer t, which is basically the number of test cases, and then each test case contains a line containing integer n. So yeah, it's my bad. I haven't explained you exactly what the problem requires. So let me just tell you that. So yeah, now let's say I told you, right, like 9876. What we basically need to do here is we need to express in the form of the rounds. Now what are rounds? I just explained you a number which its leftmost digit is a number which is not zero, and all the other numbers are excluding the leftmost digit should be zeros, or it should be a single digit. So how can we express this? We can express this as 9000 plus 800 plus 770 plus 6. Isn't this right? This and these all are zeros. This is round. Zeros, this round. Zero, not zero, round. And a single digit is always round. So that is what we need to do in this problem. So let's go to the problem. Let's go to the solution. Let's casually define a function which called uh, the like let's say gives round. Okay. And we are not going to pass anything. We are basically going to implement the whole logic inside the function. So yeah, so now what we're going to do is see we need to print out the values here in a formatted order, right? So now what we're going to do is we're going to instantiate a list answers, and we will and every answer that we arrive at, we are going to store in this list. Okay. And now we are going to start by taking the test case, which is t as input, which is t is equals to int of input. So yeah. And now what, and we need to iterate for each and every test case for I in a range of t. Yeah. Now what we're going to do is we're going now basically for every test case they are giving one value, so we need to take input one value, which is n is equals to int of input. uh, so this now we take the input. Now we have taken the input. So there is some one other point I didn't mention to you. How do you get this 9870 and 6? So uh, as I told you, if we do 9876 modulo 10, we get 6, right? So now what we're going to do is behind not behind the program, but in the program we are going to initiate I equal to 0. So basically what we'll do is we will do we will what we'll do is we will multiply for each and every modulus output, for each and every modules operation for this. Like now it is 9876 modulo 10. Next it will be 987 modulo 10. Next it will be 98 modulo 10. Next it will be 9 modulo 10. And like that it will go keep on coming. So for each and every output, what we'll have is we will do we will do 10 power 10 power uh, the I. Get it? So we will do 10 power I. Why I? Because we call it the units place, right? Like 6 is 6 is basically in 9876. 6 is basically 6 into 10 power 0, right? So 770, right? It is 76. So 7 into 10 power 1, right? So 876. So basically it's 8 into 10 power 2, 9000. So 9 into 10 power 3. So what do we see? 0, 1, 2, 3. So it's perfectly iterable for a variable such as I, which will go from 1, 0, 1, 2, 3 for this number. So what we're going to do is, so now it will be 7 into 10 power I, where I is equal to 1. So 10 into 770. Next it will be 8 into 10 power I, which where I will be 2, which is 8 into 100, which will be 800. And next 9 into 10 power I, which is equal to 3, which will be, sorry, which will be 9000. So that's what we want. So what we're going to do is we're going to take uh, just as I said, we're going to take this I and to initialize I. And now what we're going to do is uh, see, finally finally uh, at the end somehow the n we will take, it should be greater than or equal to 1, right? If it's greater than now if you remember what I told, after applying modulo function with modulo operator with 10, what we'll do is we will divide the number with 10. So basically after we do 9 modulo 10, it will give us 9, right? So we will do 9 by 10, right? So it will become 0.9, which is clearly less than 1. So now our problem is over. We don't need to do anything with the 0.9. So our base condition, we remember in every solution, you most probably will need a base case, which is n should be greater than 1. This is n, right? N should be greater than 1. If n is less than 1 at any point, then our problem is over, right? With 0.9 we don't need to do anything. 0.9 is over. It's just out of the question. So now what we're going to do is now we're going to basically define a while loop where where we put our base case, which is n should be greater than or equal to 1 at least. At least we should be greater than or equal to 1. And next what will happen is we will put the okay. So I'll tell you. I'll first code it up and then I'll explain it to. We'll calculate the value equal to n mod 10 into 10 power I, right? And then yeah. So base what does this mean basically? This is exactly this, right? N mod 10, which is n mod 10, 6, 6 into 10 power I, 6 into 10 power I. That's and it iterates. It will become 6, it will become 7, it will become 8, it will become 9. So as I will become 1, 2, 3, 4. Sorry, 0, 1, 2, 3. So yeah, yeah, and till the value. So uh, till the value is not equal to 0, we don't need the value to be we don't need the value to be 0, right? If the that's what our base case, that's what our basic condition is. If the value is equal to 0, then it's over, right? So till the value is not equal to 0, we are going to append the our answer. This is basically our answer, right? Val. We are going to append our val, and then what we're going to do is we're going to basically yeah. And see, I told you, right? After after applying the modulo, divide it by 10, so that 9876 will become 987, so that 987 will become 98, so that 98 will become 9. Basically elimination of the rightmost numbers. So basically n equal to int of n by 10. Why I did int by 10? So I've told you, right? Because 987 divided by 10 will output 98.7, and we don't need 98, we don't need any points here. The moment we apply int on it, this thing will the decimal will go and it will be converted into a integer, which is 98. Then that's what we clearly want, that's what we are clearly looking for. So yeah. So I hope it's clear, very clear till now. And now what we're going to do is if we are going to increment the one, because see, the first time it should be 6 into 10 power 0. So 6 into 10 power 0. Next time it should take 6 be it would be 7 into 10 power 1. So I should be incrementing. This is a while loop, we don't have any for loops, so that it's not a for loop, so we should increment the counter uh, by manually, right? And now what we'll do is we'll print they're basically asking the length of, like, it is two values, right? So 2, one value, right? So 1, four values, right? So 4. So basically they are asking us to print the length 2. So length of uh, months. And also what we'll do is we'll rather than just printing out the list to adhere to their format, what we'll do is for I in ans, what we'll do is print I and end with a space between them. Okay. And after that we'll give a new line after that, right? And this is the most important part. So many people will forget here that why am I doing this? Why am I emptying the list again? Because because see, here they will not give one input each time. They will give 5, 10, thousands of inputs each time. So for this calculation we'll input these values. So for the next calculation, for the 7, these values should not be in the list, so we should basically refresh the list. So what? Refresh the list, oh, for every calculation. Refresh the list for every calculation, right? So that when you get a new input, you should start a new, right? You should start a new. So that's what's happening there. So I guess this is pretty much the logic that's happening here, the logic that we need. And yeah, we have taken the inputs and all, and yeah, let's just call the function. Don't we know we should not forget to call the function view rounds. So basically, we don't need anything after this because we are basically doing all the things in the function itself. We are taking the test case number of test cases, we are iterating through it, we are defining our logic, and we are printing also. The whole thing is happening in the gives round function. So let me open terminal and let us yeah, let us check this if this code is actually working right or not. Python 3 sum right. Did you mean give rounds? Okay, it's give round. What? Haven't I? Gives round. Oh, sorry, my bad. Yeah. So now let's give input 5. Okay, 5. Let's give 500 500 and okay, and also the terms can be printed in any order. Okay, so basically we can print 5009 or 9 or 9 and 5000 or 70 800 9006. Like we can print in any order, right? So now what we will give 5009 5009. So 2, 9 and 5000, which is 2 length 2, 9 and 5000. And we will print for 9876. For remember, for 9876, the output should be this, right? 9876, which is 4, 6, 70, 809. 4, 6, 70, 809. So that is basically right. And we are going to, what we're going to do is, we're going to copy the code. We're going to go to submit the code. Let's submit the code. Some round numbers. I want to submit the code. It's taking time to submit the code. Run the test cases, I guess. Yeah. So as you can see, the all the test cases are accepted, and the verdict is accepted. So yeah, yeah. Thank you for being here. I hope you'll stick around to see more problems.